Hi everyone, my name is Gwen and I am from Eve Count Quantum Systems Singapore. Today we are actually going to talk about a QFT and Shor's algorithm. And the reason why we're going through this lecture series is because we're finding that people are increasingly involved in wanting to learn about quantum systems, but they don't quite know where to start. So this series is just kind of like a really top level overview of what you can search for. We're going to provide materials, we're going to provide maybe even some documents and essays, but at the end of the day, there's just so much information out there. So as I'm talking, feel free to just kind of follow along. And if you don't find something, pause and just go look it up. Look at the term, and you'll find that you'll enjoy perhaps the rabbit hole that you go down. You know, follow the white bunny. So we've seen small speed ups, right? And that was in chapter 4. But now we're going for the master plan. This chapter is about quantum Fourier transformation, QFT, and its crown jewel, the Shor's factoring algorithm. So if chapter 4 was about the trick, this chapter is about the engine. So let's take a look at quantum phase estimation, also known as QPE. We have a unitary operator U with a phase phi hidden inside it. We can't see phi. It's invisible to measurement, but we do need it. So QPE is the tool that extracts that phase and stores it in a register of qubits so that we can actually read it. And this is where the quantum Fourier transformation comes in. So think of the QFT as a converter. It takes that unobservable phase information and rotates it into an amplitude information. So like that, right? It makes the invisible visible. It runs in an n squared time format, making it one of the most efficient and powerful subroutines in the Inquirer quantum canon. So, what about if we don't want to do it all the way? We have something called the hybrid strategy, which is Shor's algorithm. So, this is the master plan. We don't try to factor a number on a quantum computer from scratch. Instead, we translate factoring into an order finding problem. So we use the quantum tool of QPE to find the period of a function, very much like how we use Windows and time series, right? And then we hand the result to a classical computer to finish the math. This is the classical to quantum bridge, and it's at its most powerful. So Shor's algorithm is the most famous result in the field right now, but not every problem is a factoring problem. So what happens if you just need to search a messy, unstructured database? This brings us to chapter 6 and the hammer of quantum search. It's called Grover's algorithm.